Let us look at the next step. Here you can see a target that was irradiated with calcium-48 for a long period of time, along with the expected results. At this point, we have to select what interests us. And to do so, a type of system called a separator needs to be designed. This is the principle on which the separator will work. We are still merging the nuclei. And this means that the moment when the particle merges with the target nucleus, it is completely transformed into a new entity, the compound nucleus, the mass of which is the sum of the masses of the two interacting nuclei. We hope that this will be a compound nucleus, and then, when it cools down, there will be a superheavy element that we will investigate further. This is what we really want. However, there are many events that are not associated with full fusion, but rather with the so-called incomplete fusion. That is when we have two bodies at the entrance of the separator, a particle and a target, or an ion and a target, and there are also two bodies at the exit. This is quite different in kinematics from the event when we have compound nuclei. Therefore, when we talk about the fact that it would be good to construct a fast-acting separator system, we should now say it would be nice to construct this type of separator that will operate on this principle and at a high speed so that the separation would happen very fast. This would give us a tremendous advantage in terms of gaining extra time. Let's see how these systems behave. The nucleus will move in the direction of the beam. This is both good and bad. This is good because we know exactly where it is going. If the nucleus is cold, then it would generally move in the direction of the beam. But since it will emit a neutron as it cools, it will be slightly spread, but not much, just by a few degrees, which is good. The downside is that it moves alongside the beam, and therefore we need to redirect it away from the beam. The beam is 5 × 10⁻12, and here we expect an output of 1 nucleus per day. Now this will be more difficult. In this reaction, the energy of the particles will be distributed between the two nuclei that are here. Accordingly, the angle will be larger, and in this range, according to calculations, will fall from 10⁻⁻⁴ to 10⁻⁻⁷. It's good. The principle is based on the difference in kinematics between complete fusion and incomplete fusion reactions. Therefore, the separator which we will now build will be called a kinematic separator.